Welcome to the Insituware booth here at IPC Apex. I'm delighted to be joined by my old friend and colleague, Dr. Denis Barbini. Nice to see you, Denis.
Pleasure to be here with you and Trevor, talking about our new technology that we're bringing here, launching today at Apex.
Absolutely, I'm telling you, this technology is actually right in your wheelhouse. Yeah. Tell us and our viewers a little bit about what you're doing here.
Great. So Insituware is a company that's focusing on bringing analytical tools that are typically in the laboratory to the manufacturing line. So we are taking stuff that materials and material analysis, it takes days and weeks to do in big bulky equipment, and we're bringing it to the manufacturing floor that anyone can use and do it within 3 to 5 minutes.
Really?
Yeah, so we're trying to look at filling a void in the industry, a true gap in the industry where we don't have any benchmark or any data on a given material, like paste. Everybody assumes that they've kept their paste the way it should be under the conditions of the supplier, and then putting it on a stencil printer and then processing it. However, there's no data on the paste whether or not it's suitable for use. So we've developed a technology that is based on sound science, developed 40, 50 years ago, and turning it into a 3 to 5 minute measurement. So we're giving traceability to the customer.
That is very, very significant, actually, because I mean, as many of us know in this industry, most of the defects emanate from the printer. Maybe some people say as much as 70%, but a lot of these defects are paste related. People using old paste. So if there was a system to be able to test that paste and know that it's fit for use, that would be excellent. So how does it work?
And that's a great point. The way we work it is we have this device called a Mark I. It is used as a device itself, but then the paste measurement insight is this box right here. So we have a future-proof design where if we want to just do paste, we will put this in. But if we want to do conformal coat or cleanliness or other things in the future, it's going to be a plug-and-play scenario. But with paste specifically, we are basically taking a measurement of how effective the rate of reaction between the flux and the spheres, and understanding if it's going to be compatible with the assembly process. So we're giving that traceability, we're giving that supplier, that contract manufacturer, or whoever's assembling it, the knowledge and the safety of saying, yes, we know it's going to work.
So is all that information inside this machine?
The analysis is being done in the machine, but we're doing all the analysis of any given paste at our headquarters in our lab, and that goes into our In-Situ cloud. And so our In-Situ cloud communicates with the device to do the analysis in that time frame.
So you set this up ahead of time, I'm guessing?
Correct, yes. So we're in the process of acquiring different pastes from all the suppliers out there and populating our database with that information to understand how long this paste is going to be effective for use, and then other parameters as well, temperature, humidity, and just operating conditions. We're mimicking that and seeing how the paste behaves. And then putting that into our cloud, and when the probe comes in, one of these probes right here, when it comes into our machine, we plug it in, it runs the analysis, and we compare it to the work that we've done in the lab, and we give out a certain level of assurance to the supplier, who's ever using it, making the measurement that yes, this paste is or is not in control.
So this probe here, presumably you smear some paste onto the probe, and it measures that and compares it against the database that's in your Insituware cloud, which has got the predetermined information. And what does it then give you? Does it just give you a pass, a go, no-go, or does it give you an SPC graph? What does it give you?
Well, what's going to happen is you're going to get a curve that represents the behavior of the paste, the chemical reaction. But in terms of actually setting the control limits, that's going to be dependent upon the factory, the paste, and the conditions of the factory. So a customer will be wanting to collect data and seeing how their paste works, and within a week or 2 weeks, they'll be able to make that measurement, or the upper level and lower level conditions as to where they want to have good results and acceptability. Or if it's out of control, it'll turn red and tell them that they need to take corrective actions.
Now, as I said before, a very significant move, because I mean, paste it reacts to anything. Humidity.
Yes.
Somebody opens a window, it changes in viscosity. Really, this is really a superb idea.
And so far at the show, we've had tremendous feedback. People are looking at it as a quality control tool, making sure that they have the right paste, which we can differentiate different chemistries to the paste itself. Then we also have people who are saying that they're looking at it for better yield. So maybe getting proper release, transfer of paste to the board, or soldering coalescence. So it's a number of different things, and we're getting a lot of different stories about disasters or things that they cause a lot of headaches, and that this would have filled that gap.
What about the traceability side of it? I mean, presumably you're pulling off a lot of data here.
Well, traceability is going to be over time. So you're sampling it at incoming inspection if you want, or you're doing it many times over during the course of the assembly process, and then you're going to be able to track that per day, per week, per month, per year. And then you'll see those trends and say, if there's a problem of down the road, either you can say there were some issues with the paste, we saw it and we corrected it, or you can eliminate the paste from being one of the variables that cause a certain defect.
Well, I think it's wonderful. I mean, we've got a lot of information out there for the machine side of the business, of the assembly business, but nothing that really represents the materials management. So congratulations.
Thank you.
I mean, it's a wonderful piece of equipment. Thank you for showing us that today, Denis, and we wish you every success.
Thank you.